All right, hello everybody. So today we are going to be watching the video, taking notes while watching the video, and once we're done, starting the homework. I want to remind you, because this is a video, you are welcome to pause, rewind, replay, anything at any point to make sure you're fully understanding. So our objective for today, by the end of class, you should be able to use the properties of special right triangles to find missing side lengths. So our special right triangles are the 45, 45, 90 right triangles and the 30, 60, 90 right triangles. These are our two special right triangles because their side lengths have special ratios which help us solve for missing sides. So let's start with the 45, 45, 90 right triangle. So if I take a 45, 45, 90 right triangle and reflect it over the line y equals x, I get a square. So the shape to the right here, we have a square. So in a square, there are four right angles, so all the vertices are right angles and all sides are congruent. So if I make this side be x, all my sides are x. So in a 45, 45, 90 right triangle, whatever is opposite the 45-degree angles will be the same. Now we just need to figure out what the hypotenuse is going to be. Well, luckily, this is a right triangle, so we could always fall back on the Pythagorean theorem. So, using the Pythagorean theorem, a squared plus b squared is equal to our hypotenuse squared. So, since a and b are both x, we get x squared plus x squared equals c squared. Combine our like terms. Keep in mind we're solving for c. Take the square root of both sides. And when we simplify, we get x square root 2. I don't need to worry about absolute values or plus or minus because we're talking about the side lengths of a square. So we know they're going to be positive no matter what. So a 45, 45, 90 right triangle has the properties of the two sides being the same and the hypotenuse being whatever that side is times the square root of 2. So if you know one side, for example, if we know the measure of side A is 8, that means that we also know side B is 8, and the measure of side C is 8 root 2. So we would have 8, 8, 8 root 2. Now, no Pythagorean theorem is necessary. Next example. If we know that the measure of side B is square root of 2, then that means we know the measure of side A is also square root of 2, and the measure of side C is the square root of 2 times the square root of 2, which is 2. If we know the measure of side C is 11 root 2, that means that the measure of side A and B had to be 11. And if you're like, how did I know that? Well, we know 11 root 2 is whatever side A and B is times root 2. So that means that side A and B had to be 11. Similarly, if we know side C is 12, that means we know that 12 is whatever side A or B is times the square root of 2. So solving for x and rationalizing that, we get 12 root 2 over 2, which is 6 root 2. That means side A and B had to be 6 root 2. Now, some of you guys might have enough math common sense to figure that out without having to do the math, and that is A-okay. And our last example, if side C is the square root of 18, before we do that complicated math, and actually it's not really that complicated, square root of 18 can be simplified to be 3 root 2, and now this is super easy. A and B have to be 3. But if you were to have solved it algebraically, you would have gotten that same answer. So that's our 45-90 right triangle. Opposite the 45's, measure x, and opposite the 90 is x times square root 2. Our 30-60-90 right triangle is the other type of triangle that is special because it has certain side ratios. So to find the side ratios, we are going to use what we know about an equilateral triangle. So we know an equilateral triangle has all sides and all angles congruent. So I know that each one of these vertex angles is 60 degrees. So I'm going to drop an altitude here, which means I now have two 30-60-90 right triangles. So I am going to make opposite the 30 be x, which means the whole side is 2x. And since an equilateral triangle has all sides congruent, if one side is 2x, all three sides are 2x. So right now we can already see that the side opposite the 30 and our hypotenuse is in that 1-to-2 ratio. Now we just need to figure out, well, what is opposite 60-degree angle? So again, I can do Pythagorean theorem. So I know a squared plus b squared equals c squared. So solving for, and actually let me change my variable here since our triangle down here has opposite the 60 being side b, we'll just keep that the same. So again, I'm looking for the measure of side b. So b is the variable I'm solving for. So that gives me b squared plus x squared equals 4x squared. 2x times 2x is 4x squared. Subtract x squared. We get b squared equals 3x squared. Take the square root. So we have b is the square root of 3x squared. Simplify that. We get b equals x root 3. Again, I don't have to worry about absolute values or plus or minus because we're talking about side lengths of a triangle here, which are always going to be positive. So there we go. The ratio of the sides of a 30, 60, 90 right triangle, opposite the 30 is x, opposite the 60 is whatever is opposite 30 times square root 3, and opposite the 90 is whatever is opposite the 30 times 2. So if I know the measure of side A is 9, that means the measure of side C is 18, and the measure of side B is 9 root 3. If I know the measure of side B is 12 root 3, that means the measure of side A is 12, and the measure of side C is 2 times 12, so 24. If I know the measure of side C is 22, then that means that side A is 11, half of that, and side B is 11 root 3. If I know side C is 6 root 3, then I know side A is 3 root 3, half of that. And I know side B is 3 root 3 times root 3. which is 3 times 3, because root 3 times root 3 is just root 9, which simplifies to be 3. So we get side B is 9. And then finally, if I know that side A is square root of 6, then that means side C is 2 times that, so 2 times the square root of 6. And I know that side B is the square root of 6 times the square root of 3, which is the square root of 18, which is 3 root 2. All right, that is our lesson for today. Our 30, 60, 90 right triangle and our 45, 45, 90 right triangle. 45, 45, 90 versus our 30, 60, 90 right triangle. Using those side ratios to solve for missing unknowns. Thank you for tuning in.